Hello students, my name is Ayush Sir and today I am gonna discuss standing waves. Okay, and these waves are also called the stationary waves. So in first go, I will discuss what are the conditions to form the standing waves and the mathematics behind the standing waves to get formed. Okay, and in the second go, I will tell you what is the standing wave, what are the physical significance of the standing wave, and what shape it takes after getting formed. Okay, so mainly these I will divide this topic in two level. Okay, okay. So first, uh, the conditions to form standing wave. So there are two conditions. First condition says the wave should travel with the same speed but in opposite direction. Like you can see in this figure, this is two figure. This is two figure. This is figure one and this is figure two. So there are two waves. Wave one is this. I'm calling it this wave one, and the wave two is this. Okay, so these are traveling with the same speed but in the opposite direction. Okay, yeah. And second condition is the amplitude, frequency, and wavelength of these two waves should be same. Okay, so amplitude and wavelength and frequency of these two waves are same. Okay, okay. Now this is just the condition to form the standing wave. I'm not right now. I'm not telling you the standing waves. What is the standing? What is the definition of standing wave? So don't worry, don't panic. I will tell you it later. Okay. For now, just focus on the lecture. Okay. Now the equation of wave for this wave means wave one is y1 equal to a sine omega t minus kx, y minus kx, because this wave is traveling in the positive x-axis. That's why the equation will look like this. And the equation of wave for this second wave will be equal to y equal to a sine omega t plus kx, y plus, because this wave is traveling in the negative x-axis. Okay. Okay. Now when these two waves will superimpose, then what displacement of the resultant wave will be. Okay, so the displacement of the resultant wave will be y equal to y1 plus y2. So I will put this value of y1 and y2 from equation 1 and 2. So this will be a sine omega t minus kx, this equation, plus a sine omega t plus kx. Okay, I will I will do it manually. Okay, just focus here on the screen. So this is y is equal to a sine omega t minus kx plus a sine omega t plus kx. Okay, so it will be equal to, let's take a common. So in the bracket we will be left with sine omega t minus kx plus sine omega t plus kx. Okay, bracket 1. Now y is equal to a sine. Now consider omega t minus k as c and consider omega t plus kx as d. So we can write sine c plus sine d. What? Where c is equal to omega t minus kx and d is equal to omega t plus kx. Now from the trigonometry we know one very important formula, that is sine c plus sine d, and that is equal to 2 sine c plus t by 2 cos c minus t by 2. Now apply this formula in this equation. So y will be equal to a 2 sine c plus t by 2 cos c minus t by 2. Okay, yeah. So now take 2 outside, so this will be 2a sine. Now put the value of c and d that we have assumed. The value of c is omega t minus kx and value of d omega t plus kx divided by 2, and then cos value of c omega t minus kx and d omega t minus kx divided by 2. Okay, yeah. So y will be equal to 2a bracket closed, omega kx will be cancelled out in this, and omega t will be cancelled out in this. So we will be left with sine omega t, because here omega t plus omega t will be 2 omega t, and the 2 is also in the denominator, so 2 will cancel out. So in this will be cos minus kx. Okay. Yeah. So we will be y is equal to 2a sin omega t, and again from the trigonometry identity, cos minus kx can be written as cos kx. This is a very known formula, that is not sin, sorry, that is cos minus kx can be written as cos kx. Okay. Yeah. So now we have found this 2a sin omega t cos kx, or we can write it as 2a cos kx sin omega t. Okay. So this is the equation of standing wave. Now let's move to the original slide. Okay. So this equation we have got the equation alpha, y equal to 2a cos kx sin omega t, and I have called this equation as alpha. So this is the equation of standing wave. Got it? Now from the SHM chapter, you have been knowing this equation of SHM, that is y equal to a sin omega t. Okay. So y equal to sin omega t is the equation of SHM. Now, okay, you know this equation of SHM, fine. Okay. Now, if I have considered 2a cos kx equal to ax, here x means not, this x is not in multiplied. That means the a is a function of x. Okay. Then from equation alpha, what we will get, if I will put 2a cos kx is equal to ax, then we will get y equal to ax sin omega t. Now, watch this equation carefully, and I am calling this equation as beta. Watch this equation very carefully. This equation is looking exactly like the equation of SHM. Okay, but with the amplitude ax, and ax is equal to 2a cos x. That means this ax is depending on x. Okay, that means the amplitude is variable because it is depending on x, so amplitude has to be variable. Okay, that means the equation of SHM is nothing but the equation of standing wave is nothing but the equation of SHM with variable amplitude, right? Means the amplitude ax is depending on x. That's the only difference between the equation of standing wave and equation of SHM, right? What is the meaning of this variable amplitude? The meaning of variable amplitude is this. That means every particle in the standing wave is performing SHM but with different amplitude. Got this point? Right. Okay. Now, for now, I think you have understood this. Now, let's understand. Now, if this amplitude is variable, then this amplitude values is to a cos x. So cos value can be 0, and cos value can be +1, and cos value can be -1. Okay. So when cos value will be 0, the amplitude ax will be 0. Okay. So what are those points where the value of ax or the amplitude will be 0? We have to find those points. Okay. So let's find out. So for ax equal to 0, if ax equal to 0, that means 2a cos kx should be equal to 0. Okay. That means cos kx should be equal to 0. Now cos kx equal to 0, that means this can happen only kx equal to n plus half pi. If I will put the value of n equal to 0, then it will be pi by 2. So if I will put the value of kx by pi by 2, cos value will be 0. Okay. So if I will put n equal to 1, then its value will be 3 pi by 2. Then again I will put kx equal to 3 by 2, again the value of cos will be 0. So for all these points, the value of cos will be 0, means implying the value of amplitude will be 0, the value of ax will be 0. Fine. Okay. So I can put the value of k. We very well know the value of k is equal to 2 pi by lambda. So I have put the value of k 2 pi by lambda. So pi will cancel out. We will be left with x equal to n plus half lambda by 2. Okay, where n equal to 0, 1, 2, 3 dot. Okay, means the n can be positive integer. Okay, yeah, positive integer. Fine. Now there are now, from these analysis you can conclude 2 points. What are those 2 points? That means first thing I want to tell you that the distance between two consecutive nodes. Okay, if I will put the value n equal to 0, then I will find. Now let me explain this to you. Okay, fine. So for ax equal to 0, I have got x equal to n plus half lambda by 2. For n is equal to 0, x is equal to lambda by 4, n is equal to 1, x equal to 3 lambda by 4. So now I am calling this x0 and I am calling this x1. So the distance between these two will be delta x, and that will be equal to x1 minus x0, and that will be 3 lambda by 4 minus lambda by 4 will be equal to 2 lambda by 4 will be equal to lambda by 4. So distance between these 2 points will be lambda by 4. So the distance between two consecutive points where the amplitude is 0 is lambda by 4. And one more point I want to add: the points at which the amplitude is 0 is known as the node point of the standing wave. This point, node point. Node point. And what is the condition for node point? The amplitude should be 0. Ax should be 0 for node point. Okay. Yeah. Now let's get back to the original slide. See, this is what I have written here. What I have written, these points where amplitude is 0 is called node. This point number 1. Okay. And second point I have written, the distance between two consecutive nodes. This consecutive node means the amplitude should be 0 as those points. Okay. So the distance between two consecutive points where the amplitude is 0 is lambda by 2 that we have just derived, and the distance between two consecutive nodes will also be lambda by 2. Okay, fine. I hope you have understood this point. Now we have got that where amplitude is 0, we have got the node points, and the distance between two consecutive nodes is lambda by 2. But the cost value can be +1 or -1 also. So means when the cost value will be +1 or -1, the amplitude will be maximum either in the negative bidirectional or in the positive direction. Thus the amplitude has to be maximum. Fine. So if the amplitude is maximum, that means ax is ±2a, because 2a will be the maximum amplitude. Fine. So now ax is 2a cos x plus 2a. Now I will also derive it in the fresh slide. Okay. Now let's see. Means 2a cos ax is equal to ±2a. Okay. So 2a and 2a will cancel out. So ax will be equal to ±1. So that means ax will be equal to n pi. Okay. If I will put where n is equal to 0, 1, 2, 3 dot dot. If I will put n equal to 0, kx will be 0, and if kx equal to 0, cos value will be 1, right? If I will put n equal to 1, kx will be pi. If I will put kx equal to pi, then cos will be -1. Okay, so that means cos 0 is 1, cos pi is -1. If I will put n equal to 2, then kx will be equal to 2 pi. So cos 2 pi is again 1. So yeah, that's what we want. Huh? The cos value we want +/-. So it is giving +/. Okay. So that means now again we know that kx equal to 2 pi by lambda. Put the value of kx. So we will get 2 pi by lambda is equal to n pi. So we will cancel pi by pi, and we will be left with, and here one x is also there. So x will be n lambda by 2, where n is equal to 0, 1, 2, 3. Okay. Okay. Now again from this point also, for n is equal to 0, x naught is equal to 0. For n is equal to 1, x1 is equal to lambda by 4. So now the distance between two consecutive points where the amplitude is maximum is x1 minus x0, and that will be lambda by 2 minus 0 will be equal to lambda by 2. That means the distance between two consecutive points where the amplitude is maximum is lambda by 2, and these points where amplitude is maximum are called the antinodes. What? Antinodes means which points are called antinodes? Where ax is equal to 2a means maximum. Okay, of course plus. Okay, yeah, so the points where the amplitude is maximum are called the antinode points, and the distance between two consecutive antinodes is again lambda by 2. Okay, that's what we have. Fine, let's get back to the original slide. So okay, so now yeah, so this is what I have written as point number 1 and point number 2, the points of the standing wave where the amplitude is maximum, that means ax equal to 2a, of course plus minus 2a is called the antinode. And the second point I have written, the distance between two antinode is lambda by 2, right? The distance between two antinode has to be lambda by 2, that we have. Okay, till now we have done the how the standing wave, what is the mathematics behind the standing wave, and what are the conditions for the standing wave to get formed. Now we will understand what shape the standing wave shape and what is the physical significance of the standing wave. So stay tuned. Let's move. Fine. So for nodes, now we know for nodes x equal to n plus half lambda by 2, where n equal to 0, 1, 2, 3, right? So x will be equal to lambda by 4 when we will put the value of n 0, that then lambda x equal to lambda by 4 when we will put n equal to 1, then we will get x equal to 3 lambda by 4. When we will put n equal to 2, then we will get 5 lambda by 4, right? Great. For antinodes, the equation is x equal to n lambda by 2, where n equal to 0, 1, 2, dot dot dot. So here x will be, the value of x will be 0 lambda by 2, 2 lambda by 2, 3 lambda by 2, and 4 lambda by 2. When we will put n equal to 0, we will get x equal to 0. When we will put n equal to 1, we will get lambda by 2. When we will put n equal to 2, we will get 2 lambda by 2. I have no, you can say, sir, just cancel out 2 by 2. I haven't cut it down deliberately. I will tell you why. Okay, now I am saying that I can also write this as 0, and I can write lambda by 2 as 2 lambda by 2 means I have multiplied 2 in the numerator and denominator in all of the terms. Okay, so this terms can be written as 2 lambda by 4, and this terms can be written as 4 lambda by 4, and this terms can be written as 6 lambda by 4, and this terms can be written. So just I have done just multiplied 2 in each term. Okay, multiply by 2 in each term. Fine. Yeah, this is just, I will tell you why I am doing this. Okay, now let's take a string. Now I will try to draw it separately. Now you know some points. Okay, we know for antinodes x equal to 0, comma lambda by 2, comma 2 lambda by 2, comma 3 lambda by 2, comma 4 lambda by 2, or x equal to 0, comma lambda 2 lambda by 4, comma 4 lambda by 4, comma 6 lambda by 4, comma 8 lambda by 4. This is for antinode. Now for node x equal to lambda by 4, 3 lambda by 4, 5 lambda by 4, 7 lambda by 4. Okay, now let's take a string. Okay, let's take a string in which we are trying to form the standing. Okay, now this point will be x equal to 0, of course. So at this point x equal to 0, what is getting formed? Node or antinode? X equal to 0, sir, antinode, because correct. So the amplitude of antinode is maximum, so this will be the amplitude. Fine. Now let's move to the lambda by 4 point. Okay, so this is lambda by 4. Lambda by 4, at lambda by 4, what is being formed? And node or antinode? Sir, node. Okay, so this is node, this is antinode. And now let's move to Again by lambda by 4, we will be at 2 lambda by 4. So at 2 lambda by 4, again 2 lambda by 4. Antinode, right? Antinode. Again, let's move to the lambda by 4. We will be at 3 lambda by 4. Here, node will be formed. So antinode, node. Again, let's move to the lambda by 4. We will be at 4 lambda by 4. Here, antinode. Let's move to the another lambda by 4, 5 lambda by 4 node. Let's move to another lambda by 4, 6 lambda by 4 antinode. Let's move to the another lambda by 4, 7 lambda by 4, that is node. Again, let's move to the another lambda by 4, 8 lambda by 4, that will be the antinode, right? Antinode, at antinode, the displacement will be maximum. Okay. Now let's join these 2 points. Okay. If I will join these 2 points, let me join by a different color. So I will get the shape something like this. Something like this. At node, I have to make the displacement 0. So see, at node, I am making the displacement 0. At antinode, I have to make the displacement maximum. So I am making the displacement maximum. So let's keep on doing this. We will be at node, the amplitude is 0. At antinode, the amplitude is maximum. So let's see. This is what we have got. This is node, 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 node. Now let's draw the antinode by different color. Let's draw it by this color. Antinode, 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 antinode. Okay. Yeah. Now more clear picture will be in the original slide. So let's get move to the original slide. So the picture will look like something like this. Okay. Yeah, the picture will look like this. Okay. Now, a very interesting point will come from this diagram. What is the interesting point? The interesting point is the distance between, first of all, the distance between 2 consecutive nodes. See, this node, this is the first node, I have called it as 1, and this is the second node, I have called it as 2, and this is our node point that I have drawn by black. Okay, so the distance between 2 consecutive nodes is, this node is at lambda by 4, yes, and this node is at 3 lambda by 4, yes. So the distance will be lambda by 2, lambda by 4, lambda by 4 will be lambda by 2. That we have already done. But here from the diagram, it's clear that the distance between 2 nodes will be lambda by 4. But one more thing we can infer from this diagram. What is the distance between one node and one antinode? So they see, first antinode is here, yes, that I have drawn by green, and first node is here that I have drawn by black. So what is the distance between? The antinode is at x equal to 0 and the node is at x equal to lambda by 4. So what will be the distance between? Of course, the distance will be lambda by 4. So the distance between one node and one antinode is lambda by 4, but the distance between 2 consecutive nodes is lambda by 2, or the distance between 2 consecutive antinodes is again lambda by 2, but the distance between node and antinode is lambda by 2. Okay, so this from this diagram it is very clear, because see, the nodes are being formed at lambda by 2 distance, but the node and antinode are being formed by lambda by 4. Okay, so this point is clear. So I have written here this point, the distance between a node and its consecutive antinodes is lambda by 4. Okay, now we have to understand. So we have understood what shape the standing wave takes. Now we have to understand why it is called the standing wave. Now let's understand this. So at node points, let me take a fresh slide. So see, from this diagram, it is clear at node point, the amplitude ax equal to 0. If the amplitude is ax equal to 0, then from the standing wave equation, we know that, we know that y is equal to 2a, very sorry, y is equal to ax sine omega t. If Ax equal to 0, then y will be equal to 0. Displacement, that means at node, the displacement of the particle is 0. Oh, yeah. That means if the displacement and if Ax equal to 0, then y equal to 0 means the displacement of the particle at node point will always be 0. It is independent of the time. Because if you will put Ax equal to 0, the whole y will be 0. And of course, y is Ax sine omega t. So the t term will be insignificant here. Getting the point? Yes. So at node, the amplitude is 0. That means the particle at node does not perform SHM. Or you can say the particles at node perform SHM with 0 amplitude, which is again trivial thing, insignificant, because with 0 amplitude there is no SHM possible. So we can say that at node point does not perform SHM, or the points at node are at rest. If the points at node are at rest, then from the traveling wave definition, we know that energy transfers from one point to another point through traveling wave. But how does the energy transfer from one point to another point? The particle which is doing SHM transfer its energy and momentum to its consecutive particles, and that consecutive particles transfer its energy and momentum to its consecutive particles, and that consecutive particle again transfer its energy and momentum to its consecutive particles, so and so forth. The energy keeps on traveling from one point to another point, because there each and every particle, there means in traveling wave, each and every particle is doing SHM with a constant, with the same amplitude, and by virtue of this, the energy is getting transferred from one point to another point continuously. But here, each particle is not performing SHM. The particles at node are at rest. If the particles at node are at rest, that means they will not be able to transfer the energy to its consecutive particles. If they will not be able to transfer its energy to its consecutive particles, that means energy will be confined. Where between this node point and this node point, the energy will be transferred, because this node point will not be able to transfer energy to its consecutive particles, and this node point will not be transfer its energy to its consecutive. So the energy in this loop will be confined in this loop only. And the energy is confined in this loop. It is stationary in this loop. It is standing in this loop. That's why these waves are known as the standing waves. Okay. So this is why the standing waves are called the standing waves, because the energy is confined, energy is stationary in the loop. A loop is formed between two consecutive nodes, because nodes can't transfer the energy to its consecutive particles because they are at rest, because the amplitude of the particles are zero. Got it? Got it. Okay, so let's move to the original slide. Okay, so here I have written, if you want, you can write it down. Since the particles at node are not able to transfer energy, that means the energy between two consecutive nodes is confined in the loop. That's why the wave is known as the standing wave. Okay, so I hope you have understood the mathematics behind the standing wave, the conditions which is required to form the standing wave, and why the standing waves are called the standing wave, and what shape the standing wave takes. Okay, I hope you have understood all these points. Till next time, bye bye.